the San
There you
Diego contingent is sitting back here. Jordan, he's visiting. And Laura from Newark is down for the weekend and she's visiting. So the two of them are sitting there hiding out. And Debbie is in New Mexico somewhere with her hubby. And they're trying to do it
Oh.
via the phone, but they weren't sure if they could make it work. And the Pipels are off in Connecticut. Also, Bob said he would try and do it on his phone, but he wasn't sure he knew how it all worked. So anyway, they're going to try. And I don't know where Sandy is these days. So anyway, so we're going to
Yes,
start.
She gets around too, doesn't she?
She lives in Albany, but she has a cabin here,
Yeah.
about 7
She's
miles from
often in
town.
Florida.
And her mom's down in Florida and is 96 years old. Now the whole world knows. I'm sorry. But she loves her mom and wants to spend time with her. So she comes
Oh.
down there somewhat regularly to visit. Okay, what is, oh, that's page 3. Let's turn to page 1 and get started. I don't know how many of you caught this at the very end of the last meeting. We're going to discuss the Twilight, not the Twilight Zone.
Yeah.
You two, did you ever watch those? Or you, yeah, he must have watched
Oh,
reruns.
I hate that show.
Okay. And the various aspects of astronomy that happen in the Twilight Zone. And so Ian's been very helpful this morning. I somehow couldn't find my folder with the information. So all I had was a picture taken out in Arizona at the meteor crater of the Earth shadow, which we'll get to in a few minutes because we're going to do it in order. But he put together a whole show for you here in a few minutes. But
Oh.
first, and I made him look up, and also Jordan looked up a bunch of stuff, and he's going to be giving some definitions here in a few minutes. So, Ian, why don't you answer the question, Twilight? First of all, how many times a day, this, I didn't ask him this, so this is going to be off the top of his head. How many times a day do we experience twilight?
One.
Oh,
I know.
I know. I
Okay.
didn't hear his answer.
He said very with a big question mark in his voice. One. So
Oh.
Regina, you popped in first. How many twilights do we have in a day?
2.
When do they
Even
have?
that's what I read somewhere. Dawn and dusk.
Yeah.
Dawn and dusk. That's interesting because I didn't think about it until about 5, 6, 7, 8 years ago. I just assumed twilight was in the evening at dusk. But really, twilight is both times
Yeah.
after the sun goes down and before the sun comes up. So after we got that cleared up, then the astronomers, of course, have to divide everything up math-wise. And we divided up into 3 parts. And I'm going to let
Yeah,
Ian tell you.
That was my
Okay.
assignment.
All right. Well, why don't
Okay.
you, since Ian did some of it, let him do the first one and then you could do the next 2. So Ian, what's the
Oh,
first?
okay.
Okay. Well, you got to reward him, right? He did.
Yeah.
Okay, Ian, what's the first division of twilight?
It's called civil twilight, and it's when the sun is between 0 and 6 degrees below the horizon.
All righty. So it starts the moment the sun disappears until it achieves, well, until we spin enough to make it 6 degrees below the horizon. And if you remember from week 1 or 2 or session 1 or 2, when we held our fist up to the stars and we used our fingers and our fist and our spread hand to measure degrees, I think, Regina, you're quick at this. You can double check me. Your fist, your 4 knuckles held up
Yes.
is about 5 degrees, isn't it? And if that's true, then if you turned your fist sideways and the top of it was on the horizon, then when we had spun enough so that the sun seemed to sink enough, when it's a little below your fist, that would be 6 degrees. Does that
Right.
sound logical?
Yes.
Okay.
And the
So we're-
horizon is clearly defined. At that
Yes, of course, we have trees and hills. You have to
Yeah,
live in
but
Kansas
still, you can see where the line is.
or the
Yeah.
ocean. Yeah, yeah. All right. Mary Lou, what are the next two categories of twilight?
The next two is nautical twilight,
Uh-huh.
which occurs when the center is between 6 and 12 degrees below the horizon.
Oh, the center.
Above the horizon. Isn't it above the
Below.
horizon?
No,
Below
below.
the
Oh, okay.
horizon.
'Cause
Okay,
we're
sorry.
getting dark.
And
So
the
the sun is-
horizon is distinct.
Okay, forgot
still
that.
see
You can
the
still
horizon.
see the horizon.
Yeah.
All right, and then the third
The
division?
third one is astronomical twilight, occurs when it occurs when between 12 and 18 degrees below the horizon,
Mhm.
and you can still see some sky illumination, but when it gets to 18 degrees, it's dark
It's dark.
or
Yes,
light or dawn or light when in the morning.
right. Okay, from now on, we're just going to talk about the evening end, just like we talk about the northern hemisphere. But in
Yeah.
the back of your mind, you always realize it's the opposite. It's dawn, just like it's opposite in the southern hemisphere.
Yeah.
Because we don't live on this flat disk. No flat earth. All righty. Now, Ian found something. Our next definition before we move on to specifics was the terminator line. And I jokingly said he didn't need to bother old Schwarzenegger to include in the picture, but he found what you tell him what you found.
It's a video. Let's see.
Before you start it, why don't you tell them what it is? Because they'll be so involved in watching it, they won't listen to you.
So this is a video of the International Space Station flying around the Earth. It's crossing from Iran to just below Australia, and it jumps over the Terminator line. And you can see it.
How
Go-
high up is the space station?
um,
Around the mountains, snow. There's Madagascar.
Oh, this is cool.
Mm-hmm. They're the Himalayas, my guess,
Oh,
maybe.
254 miles.
254 miles up. How many, what is it, 90 minutes to go around the Earth?
I think so.
oh, I think I see the line. Now I know what the line is. Oh,
Isn't that neat? Isn't that neat? Now we're going to
Yes.
take a look at the moon and the Earth and what the terminator lines look like on those two spheres. All right. Okay, class. When Ian quits pressing buttons, and there it is.
yeah.
What's the
That's what
difference
I thought.
between the terminator line on the moon versus on the Earth? Although it's not quite as obvious as I had hoped it would be.
So that's the line where the light terminates, huh? You might
Yes,
say.
or
Yeah.
depending on which way it's spinning, where the dark terminates if it's
Yeah,
dawn, right? Okay.
Yeah, okay. Yeah.
Alrighty. It's not so clear on this, so I'll say what it should be clearer, and then you
Well,
tell me
that's-
why. The
Those are neat
Terminator,
pictures, though.
what's that?
The neat picture.
Yes, Ian
Yeah.
found them. The moon on the left has no atmosphere. So
Yeah.
it's like, as I said to Ian, it's like Egypt. The old name for Egypt is the land of the red and the black. And you could stand with a foot on the black soil from the flooding of the Nile.
Oh,
And the other foot would be standing in the red desert soil, as sharp and clear as can be. With no atmosphere, we have a straight dark light line. You could have 1 foot in the
Yeah.
nighttime and 1 foot in the daytime. But on the earth, it's much more of a fuzzy line. Why is that?
Because of the
Because of the
atmosphere.
atmosphere.
Yes, the atmosphere bends the light and
Yeah.
creates twilight. Twilight.
Ah, very
All
good.
right. So that, okay. The last thing about Twilight, then, before we get into our really interesting stuff that you guys probably never thought about or saw, is that the length of Twilight, theoretically an hour and a half, those three 30-minute divisions, it would depend on the latitude that you are living on and the time of the season that you're in. And I remember when John and I drove to Alaska on the Alaska Highway in August, we got to 60 degrees north, turned left, so to speak, and traveled along the border between British Columbia and the Yukon, back and forth, back and forth, back and forth. I'm glad they didn't have toll booths at each of those spots because the border wiggled. It wasn't a straight line. And it, it never really got dark. I mean, the sun did go down for 2 or 3 hours, but you had twilight on each end, and the twilight lasted much longer. And then some of you, the Pipels have been down to the equator, I know, and they're probably down in Connecticut in that northeaster storm, come to think of it,
Yeah.
in 70-mile-an-hour winds, and Bob's sitting there with his new phone saying, well, I just don't know what to press next. Anyway, he's been down to the equator area, and it's famous for hardly any twilight. The sun sets, and the next thing you know, it's dark.
Hmm.
And that's partly because the earth spins faster down at the equator, remember?
Yes.
Yeah. So anyway, depending on where you live on the earth, north of the equator, and what time of the year it is, your twilight is going to vary. All right. Did anybody else, Regina, did I ask you something and I forgot to ask you what your homework assignment was?
You asked me to look up the Greenwich Observatory.
That's what I thought. Do you have any more information about that for us?
Yes, I read several websites and I printed out one from the Wikipedia.
Okay.
The first question was how old was it? It was commissioned in 1675 by King Charles II.
I didn't realize
And
it was
the
that
site-
old. Okay.
I know, I didn't either. I was impressed that this was so old and they had so much interest in this kind of stuff back then. The site was chosen by Sir Christopher Wren, a former
Oh.
civilian professor of astronomy.
Oh, he's the
And
architect?
it was-
Excuse me. Was he also the
He was
architect?
No, I don't think he was the architect. I've got that here somewhere. The king created the position of astronomer royal to serve as the director of the observatory. And this is a quote, to apply himself with the most exact care and diligence to the rectifying of the tables of the motions of the heavens and the places of the fixed stars, so as to find out the so much desired longitude of places for the perfecting of the art of navigation.
Yes. Wait a second,
Isn't that
Regina.
something way back then?
Yes.
Yeah.
Well, think about it. In the 1500s, it was the the 1400s, the Portuguese, and then the
Spanish.
Dutch in the
Spanish.
1500s.
Oh.
1600s was when England began to show her naval might, and you just couldn't sail off out of the sight of land much before Christopher Columbus, say 1500, because you didn't know where the hell you were. He was like, uh-oh, I know where I am, north or south, but geez, where am I, east or west? Anyway, so it's interesting how pure science, if you want to call it that, knowledge for knowledge's sake, has always been tied up to some extent with practical use of it. Either the king wanted to figure out how to get around the world and therefore supported the science, or for some reason, the science got going, but then had offshoots, And all of a sudden somebody said, oh, we could use this for our reasons, which were usually mercenary money. I think. Maybe that's being too harsh. Anything else then about it?
Well, you were right. Christopher Wren was the designer of the observatory.
Right.
And this was the first purpose-built scientific research facility in Britain. And I was questioning if that was, I never heard about Spain or Italy or the Dutch building any observatories. I don't know if I
Well,
didn't think about that when I was reading this.
Okay, well, you know what? Maybe keep that in mind, Regina, put it in your notebook. Sometime in the winter, I keep saying, sometime in the winter when we have time, we're going to fill up the winter schedule here before you know it. We could easily do one session on the history, because I know by, let me think, which century? I bought a book and I've given it to the library about 3-4 years ago called The Transit of Venus. Is that right? Yes. In the 1800s. And you may or may not know this. Jordan knows it because when he was 6 years old, I dragged him out of bed. What year was it when you were 6 years old? 2004. In 2004, after something like 150 years, we could observe the transit of Venus. And then 8 years later, it always comes in a pair, 8 years apart. And then another 150 or so till the next one. Even you won't be alive by then. But whenever it was in the 1800s, you had many of the nations around the world all collaborated because, I'm sorry, now I'm doing it my Mrs. Webster detour. We didn't know how far it was to the sun back then, but somebody clever decided, oh, if we went to these far apart places on the earth and were very accurate with our clocks and our telescopes, and we could time exactly when Venus first touched the edge of the sun, and then when it left the other side of the sun, and we did all our complicated geometry, we could figure out how far away the sun was. Anyway, the Russians went, the Germans went, everybody went, like 8, 9, 10, 12 different countries. And it was a huge expedition adventure in those days. And then 8 years later, they did it again. And then because they had all that experience the first time around, they got much more accurate results in the second time around. But how did we get there?
When was the first time?
Okay, so Jordan, look it up on the transit of Venus in the 1800s. When was it?
Oh, that was back in the 1800s.
Oh, yes. Ours was in 2004 and then 8 years later. And Jordan, hi, Sandy. And Jordan and I saw it at 6 a.m.
Wow.
Using the binoculars turned backwards with a piece of cardboard in the window of it. And it was just so fascinating. Well, we tried to see the transit of Mercury here. Was it in the fall of this year?
I don't remember.
At the library, and I even made cookies, a little tiny chocolate chip and a bunch of flat orange round cookies. And the chocolate chip kept moving across the cookie. Anyway, and we had it all set up. We were going to have people here and everything. And it was cloudy all day long.
Cloudy, yeah.
So we had it on the computer. And it was like watching paint dry.
Yeah.
Anyway. Hi, Sandy, can we hear you? Hello?
Yes, hi.
Hi, greetings. Where are you? I always have to ask.
I'm at home. I had to get my car re-inspected.
Oh, okay. Well, Jordan and Laura are here. Jordan's from California, but we finally got them in the room here. And Laura's also, but they're out of sight. They're sitting in the corner.
Okay.
All right. Okay. Moving on. Where are we? Fuzzy. Length of time. Alaska. Okay. The next one. Do you want to pronounce it? I'm not sure.
What one?
That one. Sounds like a dead planet.
Crepuscular.
Doesn't it sound like some yucky disease?
Crusty.
Okay. Crepuscular rays that happen at sunrise or sunset. We're going to deal with a sunset. And Ian found a whole slew of pictures. And I don't know why I chose this one.
Want a different one?
And I hadn't thought of it, but was it Jordan, was it you, or was it Ian that found, they both did a lot of research, Jordan and Ian, before the program on all these new terms. But we've all heard of sunbeams. So usually when the sun is close to setting, or the opposite, rising, and there's these open type clouds in the sky where the sun's rays can shine through them. Once again, it has to do with the atmosphere and the bending of light and what appears to be these beams shooting out sort of like along the radius, right, from the sun. But in truth, once again, that's sort of an optical illusion of the atmospheric particles bending the light. In truth, of course, the rays from the sun are parallel to each other when they strike us on the earth. So, has anybody ever noticed this phenomenon?
Yes, I've seen it.
Okay, speak up so that, can you hear the voice from the back?
The wizard behind the curtain.
Yes.
Where were you? Can you remember where and when?
Various places. Can't think of where offhand.
All right. Who else? Anybody else ever see these? Sandy and, oh, okay. So I can't see. Regina, you got to wiggle the phone image there and then we know you're waving. All right.
Oh, I was on mute. I don't
Okay.
understand. What are you asking to see what? I didn't get that.
Okay. The
She can't see the picture.
oh, you can't see the picture.
Yeah.
I'll tell you
The
what. Let
light-
me. Okay.
like
how
in the
can-
movies when God speaks.
Oh, that's okay. Don't bother.
Oh,
That's
really?
okay. Don't bother.
I've
The
never
heavens
seen a
open up.
movie. Oh,
And it
Ian
looks
says
like-
in your imaginations, if you've ever seen a movie when God talks and the heavens kind of open up, you don't see God.
Yeah.
That's what it looks like.
Yeah.
The light shines through
Okay.
the
What kind of movies do
All
you
the bright
watch?
rays, like,
Okay, but usually it's near sunset or sunrise, and they seem to span out from like the radius from the sun at angles, but in truth, they're really parallel. It's just something to do with the atmosphere tricking our eye. All right. Now, Ian, is there a way that Regina would be able to see these? Could we print out one or two of these images?
Yeah.
Like we do our star map?
Mhm.
Regina, just for you, we are going to print out. Can they all be on one page?
Yep.
Okay. Ian will print out the 5 or 6 images we found for today. Will they be in color? Well, their
Depends.
color machine is kind of weird, so it'll be in the weird color of the color machine. And then you can pick up a copy, Regina, along with your,
okay, thank you.
okay, monthly star map. Okay, that's page 1. Page 2. The green flash. Now, I'll be really jealous if anybody has
Mary
seen
Lou has a
this.
question, I think.
Hmm?
I think Mary Lou has a question.
Oh, Mary Lou, I'm sorry. Yes, what? We can't hear you.
She's muted.
Unmute.
Okay, be sure you include a picture of the Terminator line for her.
Yes, okay.
Yep.
Good idea, thanks.
Okay, so we'll run off a couple of copies then, because you want one, Mary Lou? And,
No, I don't need one.
oh,
I've seen it on the computer.
okay.
Yeah.
Now, I'm guessing, you think that's the ocean?
That's what
Yeah.
it looks like.
Okay, that looks like an ocean to me. Who knows where? There we go. And forget the red in the sky. Sometimes, on the computer, they fiddle around. What do they call it? Enhancing.
Yeah.
And
Photoshop.
it's not really what they saw. It's like when Jordan took the picture of the full moon, what he saw and what the camera took was 2 different things. So anyway, forget the reddish sky. I don't know what's going on there. But if you've ever really watched a sunset, as it gets very close to disappearing, it loses its nice, sharp hemispherical shape, and it kind of bulges out like that and gets a little wavery around the edge. But according to the research, if you're watching the last 2 to 4 minutes after the sun sets, well, that it didn't quite set at that point. During that 2 to 4 minute span, when it's just about setting to just afterwards, you may see a 1 to 2 second green flash. So you have to be in the right place at the right time and look exactly to see it.
Like sea level, like somewhere like sea level or
Yes,
something?
I think that's true. You, once again, good old Kansas. I think it would be hard because we never really see the sun at this point here
Yeah,
because of the hills.
yeah.
I'm guessing.
Wouldn't it be a bad idea to be staring at the sun though? I mean, for your
Not when
eyes?
not when it's that low in the sky, Sandy. There's
No?
so much
Okay.
atmosphere between it and us. It's, you can double check. I don't want to be sued by giving out the wrong information. Not that you friends would do that, but who knows in the world that's going to be listening to this. Double check it, but I'm reasonably sure that I've read and I've watched the sun go down and I still can see pretty well. But there's that momentary green flash. And once again,
Didn't
think,
Oh,
what?
you say it was when the sun was below the horizon?
Yes, that's what they, Jordan, you looked it up, right? It was just when the sun just dipped below the horizon, right?
Yeah.
So
The top of the sun?
oh, I know
The
what's
top of the
happening.
sun?
Wait a second. Very good, Regina. You didn't realize what you've just asked, but let me think. When we see the sun at this point setting, it's already set.
yeah.
It's like a mirage. Once again, because of the atmosphere bending the rays of the sun, we actually get about 2 to 3 minutes extra sunlight in the morning and in the nighttime than in reality, which is hard to, to grasp. But it's like the mirage out. You've all driven out in the West or the Midwest on a hot summer day, and the road starts to shimmer, and then you see a mountain, or you see the water, or an upside down house. Lots of times the bending of the light flips things upside down. So at this point, that sun is actually below the horizon, 1 or 2 degrees, and you're seeing the optical illusion of the light being bent.
I did not know that.
I didn't
But
either
wouldn't that be
until
also-
these, pardon? What,
Isn't that
Regina?
also because of the speed of light? That
Nope.
the speed of light is
No.
carried that, no?
No, that would be not even a second, the speed of light. No, it's simply due to the bending of the light by the atmosphere. You could look that up. How would we word that to find out? Am I really seeing the sun as it's setting? Maybe that would get you to that area of expertise. Well, Ian's going to try and find it. But the reason we see the green is that, once again, go back to Newton during the plague when he had to quit teaching and go home. So he had nothing to do. So he got bored. So he started fiddling around with this and that, including, how can we get that on screen? Ian's going to be fiddling around here to get a picture of what's going on. But what Newton, one of the things he did to pass the time was to take that prism, shine the light through it, and voila, the rainbow or the spectrum on the wall. In other words, a prism or the atmosphere, all those little particles of oxygen and nitrogen and water vapor, like a prism, break up the light, bend it, break it up into its 7 colors, Roy G. Biv. And the red, yellow, and orange wavelengths of the white light are bent below the horizon. You don't see them anymore. But what passes through to us are the blue-green end. All righty. Oh, well, that doesn't really explain it. Here's a picture of the Earth on my right. Hey, Jordan, there's San Diego. And the horizon, nice parallel line to the bottom of the screen. The true position, you see, is already below the horizon, out of sight. But because of the bending, we think we still see it. Oh, I like that. I'd forgotten that. I knew that and I'd forgotten that. All righty. If anybody will give a gold star to whoever finds out why. All right, let's see. Bends, leaves. They say that the green flash is easier to see at the dawn when the sun's coming up than vice versa, because your eyes, you'll see the green flash before the sun comes up. So your eyes are adjusted to the dimmer light and the green will be more obvious. When it's setting, you're kind of blinded by the light, that old song I used to like, and it'll be harder for you to see that brief green flash. So early birds up at dawn. What's our next picture? The Earth shadow?
Yeah.
Okay, did anybody, the people that were at the bird sit, we talked about the Earth shadow, but because of the spruce trees, we couldn't see it. And it was also sort of cloudy. So the only picture in my collection I could find, which meant Ian had to do some hunting, was this one out in Arizona at Meteor Crater, where I actually was once at dawn. And we see a full moon. Is that sunrise or sunset?
Does it say on there?
No, I don't think, maybe, does it? I don't think, I'm trying to think of
It says
having
moonrise,
moonrise.
so sunset.
So it's looking east with the moon. So I'm looking back towards New Mexico from the crater, which means, well, I have to think about that. Anyway, this, once again, and any of us here can spot it, and we've probably seen it lots of times and never realized what it was or thought about it. What's the Earth? What does it mean by Earth's shadow? Wait a second. No, that's not right. No, this is sunrise. And the full moon is setting in the west because the Earth's shadow is opposite from the sun. How's that for deductive thinking? See, you just don't press buttons and get the answers. You got to figure things out for yourself. If you understand the relationship between the sun, the moon, and the shadow, then you realize this has to be dawn. And it's a full moon, so the moon is setting. The behind me in the east is the rising sun, because the Earth's shadow is always opposite the sun. Anybody know what's happening, or do we want to draw pictures again?
Well, nighttime is coming to the parts that are in the shadow, right?
Yes. Yes. Okay, what I want you to do is, I actually drew it out, but maybe in your mind's eye, you can picture it. Let's picture in your mind's eye the sphere of the Earth right in the middle of your closed eyes vision. And the sun is over here in the east. And the reason we have sunrise is the Earth is turning into the east. So your left hand is on top of the Earth and it curves around, well, sideways, turns around, and then gradually that terminator line moves, right? And that means the nighttime is behind you at dawn, right? You're leaving the nighttime behind you in the western sky. And so if you turn around from the dawn, just before the sun rises, and look to the west, or it would depend on the time of the year. If only at the equinoxes, east-west, other times, you know, the sun is different. So opposite wherever the sun's going to come up in another 5 minutes, you will see this grayish bluish band called Earth shadow, because what that is the shadow of the Earth. Maybe can you find a diagram like I drew? The sun, here's the Earth, and then the shadow of the Earth, which is nighttime. So you're in a sense seeing the edge of nighttime, which is not totally dark.
So you're
And
seeing the terminator line.
on the ground it would be, but this is up in the atmosphere.
Oh, okay. So
then-
the dark ground and then the light brown at the bottom of the picture isn't your terminator line, huh?
Okay, let me see. Squint. What does it say for this? What does that say?
It's in the wrong
Day and night
position.
cycle diagram.
Try for Earth shadow and see if you can find anything there. I'm sorry, guys. We're trying to find a picture that we can.
Oh, okay.
You could draw it right now. You guys got a paper and a pencil in your arm's reach?
Yeah.
Okay. In the middle of your space, draw a circle that represents the Earth.
Yeah.
Okay. And over to the right, draw another circle and put some sun lines around it, so, or an S. So that's sunshine. All righty. Behind the Earth is in a cone shape, right? The dark isn't everywhere. It's just we can't. The Earth blocks out the sunlight, so a cone shape behind the Earth, and I don't know how far it goes, is our nighttime. Okay, so from the top of North Pole, South Pole, you draw like make an ice cream cone lying on its side to a point. And then,
Oh, and the point is away from the Earth.
yes. Yes.
Okay, I got it.
Okay, and then think of the sunshine hitting the side of the Earth towards it, our daytime. I'm looking here at what Ian has found and trying, it doesn't look very clear to me though. I wanted a sideways view. I think they're getting it. And so as we turn into the sunrise, we're leaving behind that shadow. And so it doesn't disappear, bang, just like that. We see the edges of the night, but it's not total, it's more like a twilight. Okay, that's a better one. Do you think that makes it clear?
The sun coming in.
Okay, all right. Maybe Ian found something that's sort of clear. Why don't you try and put it on? That pink band above, and someone might want to find out why. It's called the belt of Venus. And I have no idea why. I couldn't in the books I had, since I don't have the magic computer. Ooh, we gotta talk about things like that sometime too in the winter, the halos. Because sometimes meteorology and astronomy are intimately tied because the one won't happen without the other. Is it, and you kind of grew up with this, and you too, Jordan, but to me, this is so magic. How can a flat screen with a bunch of buttons contain all this information? So that's, again, once you find it, you guys can look this up at your leisure. You all have computers, and pursue it if it interests you. So Ian found this image of the person standing on the Earth. A bit blurry, that's okay. That's all right. And how, as we turn into or away from, it depends on if it's morning or night. Part of that shadow is above, we get to see it. So anyway, okay. Anybody on that murky topic have more murky questions for your murky leader?
Well, actually, I just have a idea. So the Earth's shadow really never moves, right? It's just the planet, the surface of the Earth is moving in and out of it.
Yes.
Is that right?
We and it move around our orbit, of course. So in a sense, it does move through space. Right?
Oh yeah, that's right.
Yeah. And then the
you're
galaxy, all these movements we're doing that we're not aware of. We're just sitting here still, right? No, we're not.
Yeah.
So yeah.
Well, I just got that idea from my drawing on the paper.
Okay, Sandy, what?
What is this belt of Venus? Did you already talk about it?
Well, that's the pink band. You want to go back to the image we had of Arizona? The pink band above the shadow was named Belt of Venus, and I don't know why.
Oh,
But
okay.
so Sandy, why don't, for next time, you find out why they named it that. See, I don't have access to all this information. I have like 7 books, plus what I happen to remember from other things. So my information just gave me the name, but it didn't explain where it came from. All righty. 2 more things. And I have been trying for years to see this, and I've never succeeded. The Zodiacal Light. And once again, you guys with your computers, there's lots of images there that you can find. I chose this one. However, it's never that bright, which is one of the reasons it's hard to see. They say the Zodiacal Light is pyramidal shape over the spot where the sun, we're talking about night, also dawn, where the sun set, this pyramid of dim light. And by dim, I mean dim. It's comparable to the Milky Way. If you live in the country, and y'all, we've seen the Milky Way, it's only as bright as that. So it's nowhere near as bright as this. Whoever put this picture on decided they had to make it brighter. Can you make it dimmer? No, okay.
Not right now.
We won't do the paint shop. All right, so what is it? And where do we look for it and when do we see it? Does anybody know? Before I babble on. Jordan, you looked it up. Why don't you tell us?
Which thing?
The Zodiacal
I
Light.
didn't look up that.
Oh, you didn't look up.
It's before
We'll
morning dawn breaks or after evening twilight ends.
Can they hear? Did you hear that?
No,
Pick up.
It's before morning dawn breaks or after evening twilight ends.
All right. So that would be twilight. We decided was an hour and a half. So whenever the sun goes down, an hour and a half, where you go talk about the sundown. Whenever the sun goes down, an hour and a half later is when, for maybe a half hour, you'll get to see this faint glimmer of light. What causes it? Does anybody know?
It's caused by sunlight that is scattered by an interplanetary cloud of tiny dust particles orbiting the sun and reflected toward Earth.
All right.
Yeah.
Okay, you want to, that's okay. All right. Remember in the beginning, all those billions of years ago, it was all just a cloud of dust, gas. And eventually it got sorted out. Oh, that reminds me. Jordan, don't forget, you got to talk about the planets that ran into each other. So think about that at the end. And gradually everything settled out. We wound up with the sun and all the planets and the asteroids and some comets and this and that. But there's still a lot of dust out there. I mean, you might have to travel 10 miles before you find one little speck, but still, seeing how big it is, there's a lot of dust out there. And up until 6 months ago, they thought the Zodiacal Light was simply, it's concentrated in the orbit of the Earth. And the sun bounces off of it and bounces back to us. And the best time to see it is during the equinoxes in spring. No, yes, the equinoxes in March or September. And that's because the angle of the Earth at that point in relationship to the orbit is such that it enhances our being able to see it. Quiz time, see who remembers. About 2 months ago, I heard something on the news that I thought was quite exciting. All this research that's done, and lots of it done sits for years before they find some poor graduate student. They say, you know what, 10 years ago, we did this research and I haven't had a chance to get around to it. This is what you're going to do this year. And that's exactly what happened. Does anybody remember what most of the dust particles are made of? Do you remember when I forget what year it was, the first time we had an orbiter going around Mars, and they were so excited they were finally going to get close-up photographs. And all of a sudden it was like, hey, what happened? Can't see a thing. The whole planet Mars was shrouded, that's such a word, in dust, because we now know that Mars is a desert pretty much, and it has a lot of iron. It's all red dust, red rocks, red dirt, and they do have winds, and every now and again, superstorms churns it all up. Most of the zodiacal light is dust from Mars.
Oh,
That is in the orbit of Mars, and the orbit of Earth is pretty similar. And so it's all out there from the dust storm. Okay, now Jordan had to look up. Where is it? Look, Jordan, and
So the dust is iron?
iron, well, yeah, dust from rust floating around. Dust, iron dust.
Rust.
Iron
Yeah.
oxide.
Okay.
Iron oxide. Thank you. Ferric, I think, not ferrous, right?
wow.
You weren't. a
Iron oxide.
Were you?
Okay.
No, but you remember. Okay, Jordan had this one for his assignment, so I'm going to let him read what he found. Good and loud, Jordan.
Okay, it's for the nocturnal. Right?
Yep.
Okay, so these are clouds that are in the polar mesopause portion of the atmosphere, which is about 50 miles high. And they're only visible when the sun shines through them. And they're brighter in the northern hemisphere, far less frequent in the southern hemisphere. And they're found in summer at about 60 degrees.
All right, so the best time is to go up to where I was talking about the border of British Columbia and the Yukon at 60 degrees north, give or take a few degrees on either side. And in the summertime, because obviously up there in the wintertime, the sun really isn't in the sky very much, and you have to have the sun somewhere near you. You know, you have to have some daytime light. These clouds are probably cirrus clouds, thin ice clouds. At 50 miles, you're getting to the edge of, now I used to know this, the various levels. The stratosphere is what, 30,000 feet? Well, 50 miles is 50 times 5,000. That's way up high. Couldn't breathe up there. Your parachute wouldn't open up there. So it's way, 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 way high, thin ice clouds. And they're so high up that the sun, which is, this is not any kind of twilight. This is just those clouds in the dark. It occurs at least an hour and a half after the final twilight. Is that right? Did I write that down, or an hour and a half? I think so. It's really dark out when this happens. Now, an example would be if you've watched the sun go down, all of a sudden a plane that's flying at 30,000 feet goes over, and you can still see the plane in the sunlight, right?
Mhm.
Yes.
Okay, this is just a more extreme now, but maybe 20 minutes after the sun go down, you can't see it anymore, even though it still would be the same height. But these are so high up at 50 miles, not just 5 miles. The sun can be further into the night, and it still reflects on them. So I thought, geez, I've never seen them either. But I don't live that far north. So anyway. Any questions? What time is it?
150.
What time?
150.
1:50. We have 10 minutes. I have assignment questions, but does anybody have any questions on all of this? I find the twilight. Oh, you know what I didn't talk about? Earthshine. But we went over this when we talked about the moon. So we're not going to talk about it, but you can think about Earthshine. And I want Jordan then to tell, Jordan has this magic box and he pays attention to everything that's going on in the world. And the other night he said to me, what did you say? oh, good heavens, or oh my gosh, or gee whiz, or that's what I would have said. I forget what he said. But it was totally amazing because a few months ago, we spent 3 sessions on the moon and we talked about the theory of how it was formed, Gaia. Very shortly after we were born, probably still molten with no continents, just a big ball of hot lava spinning around. And along comes something the size of Mars. Wacko. Boom. Eventually a moon. Well, Jordan, tell them in a good loud voice so they can hear. What happened just what? They just
a week
discovered
ago.
a week ago? Okay, you take the story.
I guess they've been looking at a planet called, it's just a number, but it's HD 17255. It's a planet that's about the same size as Earth. And they recently saw that, well, what they think, this happened at 200,000 years ago, but they just saw it, that something that's probably the size of the moon collided into the planet and completely destroyed its atmosphere. It's completely stripped it off the planet. And they can tell this by looking at the gas around the planet, that all the carbon dioxide has been sucked out into space and is now circling the planet.
Okay, so this was an exoplanet in the last 10, 15 years, 20 years ago or 30 years ago, when a lot of people were skeptical. The Earth was the only one. Couldn't possibly have other planets out there that were habitable, Goldilocks planets, just right for life. Well, times have changed as our instruments have gotten bigger and better. Now we're finding galore of planets, exoplanets they are called. So this is one of those exoplanets that obviously was 200,000 light years away. Back in 200,000 years ago was the end of the Permian era, or whatever they call it, one of the big extinctions. That's when it happened, but it was so far away, and it took that long for the light, which goes really fast, to get here. And they think it looked very much like what happened probably to the Earth in Gaia, as they call it. So, wow, I was right. Can you imagine being the grad student that had the night duty and he's sitting there? Oh, wow. Anyway, that does happen once in a while. Mary Lou, what? Ready for your assignments?
Yes.
Okay.
Yes.
We're going to, that's not the assignments. Where did I stick them? Oh, here they are. We're going to have really toe-wiggling fun next time. I want to know, how do we know how far away things are? We basically say, the sun is 93 million miles away, give or take a few. The moon is 250,000 miles away, give or take a few. This event happened 200,000 light years away. Well, you could convert that into miles, but it would take up a lot of paper. How do we know all this? So, assignments. Debbie's not here. She's going to look up the distance of 1 light year and then 1 AU. And that does not mean the university. What does it mean, somebody?
Astronomical unit.
Astronomical unit.
Yes, which is what, guys? What is that in miles or whatever?
The distance from here to the sun.
Speak up. Did you hear him?
The distance between the Earth and the sun.
Did you hear that, Sandy?
He answered that without using his phone.
Right, roughly 93 million miles. Okay. Then I was going to, Mary Lou, you ready?
Okay, yeah.
What's the distance to the moon and to the sun in miles? Sandy? Ready?
I probably won't be live next time because I'll be with my mom.
Okay,
So I'll try, but I
but
may have
try.
to do the recording.
Okay. In AU units, astronomical units, what's the distance to the 4 rocky planets? Mercury, Venus, Earth, and Mars. Rima? You can tell Rima's assignment, Ian, or you can do it for her. The distance in AU units to Jupiter, Saturn, Uranus, and Neptune. Okay. Regina,
It's
Yes.
just the
Okay.
sun or the earth.
from the sun, Sandy. Okay, I gave you a slightly tougher
Okay.
one because you might have to also explain what they are because we really haven't talked about them. What is the AU distance to, I don't know how to pronounce it.
Kuiper. I think it's Kuiper.
Kuiper belt, Kuiper, I think is belt.
Okay.
And what is it? And then the Oort cloud. How far out in AUs is that? And what is it?
Now spell that cloud.
That's easy. ORT. Named after, both of these were named after some men who were astronomers and who either discovered them or studied them. And came
I'm
to.
confused.
So
Yes,
what is
Marla.
it and
But
Okay, what is it and how far out in AUs is it from the sun?
okay.
And then I'm going to give
I think Sandy has a question.
I have
Sandy.
a
Yes, thank
question
you.
about-
Ian.
And I thought that you said the AU was the distance from us to the sun. So
Right.
the other planets you're talking about less
In-
than one. Is that it? I mean,
Well,
you're
for
talking
Mercury
about-
and Mercury and Venus, yes, but Mars,
Oh,
no.
Okay. All right. All right.
Yeah.
Okay.
Yep. Sixth grade fractions. That's where the kids start having trouble with their math when you go do fractions, right? Okay, and then I'm saving for Bob and Ann the real toughie, and I finally found an article that explained it, and I sort of skim read it and thought, no, I got to do this when I'm more focused because it wasn't an easy article to understand, but evidently, oh, I didn't assign anybody. Jordan, did you have an assignment?
So what was Ann and Bob's assignment?
I haven't got told it you yet. This using Cepheid stars to tell the distance, and those are let me think. Binary stars that get bright and dim at a certain rate because they're spinning around each other, and one is darkening the main one for a short while. We haven't talked about those yet, but somebody discovered, and I don't know how, it's not simple math, but I'm going to figure it out, and Bob and Ann can figure it out. You can use a binary star in Cepheus, the first one that they discovered, you know, that constellation next to Andromeda, no, next to the W. Help me out here, I'm losing my mind. Up around the North Pole, the Big Dipper, the Little Dipper, Draco, right, the one I can't remember. Anyway, Cepheus, the king, a double star in his constellation that went bright, dim, like in a 3 or 4 day period. Somehow they figured out how rapidly it alternates to determines the distance. But once again, I can't explain it right now. So we're gonna let Bob and Ann look, and I'll look it up too. Okay, Jordan, I was gonna give you something. What was it? Oh, back in the day, we did go over this, but it's fun to go over it again. And if you would like to research those Greeks way back around 200 and so BC, who figured out the distance to the sun and the circumference of the earth using simple geometry. Okay, these other, once we got past the simple geometry, as I said, until the transit of Venus, we didn't know how far we were from the sun. I mean, how can you tell? So anyway.
I know, I still can't understand it.
I can understand. Do you all have 3 more minutes? Because, okay, I can give you an example. Take your finger, look across the room and pick out an object. I don't care what it is, a lamp, the end of the picture. hold your finger out in front of, or your finger out in front of you so that it covers up the lamp with your one eye. I don't care which eye you use.
Right.
Yeah. And then look at the finger against the background with your other hand. What's happened? With your other eye, what's happened?
It moves.
It
Huh?
moves.
What?
It looks like it moves.
Your finger moved, but did your finger move?
No.
No,
No. That's called parallax. You have two eyes. And if you
it's
Okay.
called what?
we have two parallax, like parallel.
Parallax.
If you were born with one eye, you would have, as a baby, and as you grew up, you would have no sense of depth perception.
Yeah, yeah.
You would have no idea how far away that, for me, the books on the wall are. We only know that through gradual experience as a very young baby and a young child. Our two eyes are really seeing two very different things, but our brain is putting it together, and then the brain is saying it's 6 feet away.
Yeah.
Now, we had a Volkswagen back about 50 years ago when they just hit the market in the US. And after Volkswagens had appeared in the US, about 6 months later, some insurance company noticed a statistic and thought, well, this is strange. What the hell's going on here? All of a sudden, Volkswagens, against the odds, against the statistics, were having these accidents at night where they're going down the road and they're making a left turn in front of oncoming traffic. And all of a sudden, they started having more than they should accidents. The person coming towards you was hitting the Volkswagen. What's going on? So who knows what was going on?
Well, they didn't have that parallax view, I guess.
Has something to do with
Is that
that.
right?
Curve of the windshield or something.
No.
The light.
What about the
Something at
light?
night.
What about the lights on the Volkswagen compared to an American car?
Oh, they were spaced differently.
They were smaller.
Oh,
And what we had done is we learned to drive. And any parent that has gone through teaching their kids to drive, don't look at her, she says. I remember you driving across the Blue Bridge in Kentucky, first time. Anyway, as you learn to drive and experience night driving, you judge the distance of the car coming towards you by the size of their lights.
yeah.
And of course, the closer they are to you, the bigger they are, and you learn to judge, do I have time to turn in front of him or not? But the Volkswagen all of a sudden had a smaller headlight, which meant to your little brain, it's further away. I have time to turn.
Yeah.
No,
Oh,
you didn't, because it was
Oh.
closer. So the same kind of thing is going on. Instead of our two eyes, we now have the Earth, the diameter of which is 8,000 miles. So if I take a picture of, say, one of the planets against a background of stars. Now we know the planets are closer to us than the stars. If I take a picture of that relationship in June, and then the Earth travels around its orbit, all that distance. Oh, forget the 8,000 miles. Your telescope is at the same spot on the Earth. I'm sorry. You travel around your orbit, which is 2 times 93 million miles. Now you've got two eyes spread 2 times 93 million miles apart, and it's the same as your finger. Oh, when you took the same picture, that planet compared to, or a closer star compared to the background, shifted seemingly. And then you can do the just plain old geometry, I think, and figure out how far away it was. But if you're interested in that kind of detail, then you can look that up. And to me, it's just fascinating how you use your reason based on observation to come to probably truthful conclusions. Otherwise, we'd still be saying the celestial sphere out there, all the stars are stuck on the inside of it and they're all the same distance away. Okay, stop rambling. Did everybody get an assignment then?
Yep.
Yes,
Okay, all right. Well, what's 2 weeks? I think it's the 9th of November, give or take a day.
it's November 9th.
Okay, so hopefully Debbie will, for where they were in Silver City, New Mexico, they're only at the most 100 miles away from the famous book that was written in the 30s, The Sea of Grass, the first American novel in which the landscape was a character, and they made it into a movie with Spencer Tracy and Katharine Hepburn. Well, I drove through there. It's at about 6,000 feet, maybe a little over 100 miles by 60 miles, all grassland, basically, surrounded by mountains. And in recent times, I don't know exactly when, they have a huge series of radio telescopes. Oh, that's what Jordan's assignment was going to be. Green Park, West Virginia.
Oh, yeah.
Yeah, another famous radio telescope. And everything we've been doing so far has been based on our sight. Telescopes that see a very narrow band of electromagnetic energy, the visible light waves that we see. But there's several on the one side and several more on the other. And little by little, astronomers are harnessing those bands like microwave, radio wave, infrared, ultraviolet. And it's telling us more and more and more about what's out there that we can't go and touch ourselves and look and see. So after we study the distance, we're going to ask, well, how do we know what they're made out of? That's even more fun. Okay, any last questions before y'all go? Okay,
Sandy has one.
Sandy, or was that a wave goodbye? I think that was a wave.
Wave goodbye.
Okay, goodbye. Oh, thanks for your jars. They're all filled up with cider in the freezer.
Oh, excellent, excellent.
Okay.
Bye.